In this lesson, I will explain to you how to calculate the probability of dependent event. So first I will explain to you dependent event, then we will solve some questions in order to make it clear. Two events are dependent. See, dependent if the outcome or occurrence of the first event affects the outcome or occurrence of the second event, so that the probability is changed. Now, what does it mean? That if the outcome of the occurrence of first event affects the outcome of the other event, right? It means both events are related. Suppose if you are attending the class 100%, so definitely you will get A plus. So means your attendance is related to your grade. Your attendance, or you can say your grade depends on your attendance. Second example, suppose if you park your car in a disabled parking spot, then definitely you will get a ticket. So ticket depends on parking spot, right? So same thing. If the outcome or occurrence of the first event affects the outcome on the second event, in this way the probability is changed, and this is called the dependent event. So here I have mentioned the same example, having 100% attendance and getting A plus, parking a car in disabled parking spot and getting a ticket. So this is the important note. In order to calculate the probability of a dependent and independent events, we use multiplication rules. While in order to calculate the probability of a mutually exclusive and not mutually exclusive events, we use the addition rule. So here we will use the multiplication rule with a little bit modification in notation. So in order to calculate the probability of dependent events, use multiplication rule with modification in notation. So what is the meaning of this modification in notation? I will show you in the next slide when we will solve the question. When we will solve the questions of an independent event, we normally just multiply the two probabilities, right? Suppose a card is drawn from a deck, and deck has 52 cards. If I draw a card randomly, any card, and I am not going to replace it, how many cards are remaining in the deck? Then I have 51 cards, right? So when I will pick another card, it will affect the first event, because in the first time I had 52 cards. Now I have only 51 cards. So the question is, a card is drawn from a deck and not replaced. Then a second card is drawn. What is the probability of selecting an ace? See, first is ace, first time, and what is the probability queen on the second card? So you have two events. First is A, second is ace, and second is the B, queen. So probability of ace is 4 by 52. Why 4? Because there are 4 aces in a deck. So what is the probability of selecting an ace? You have 4 aces. We can write down 4 divided by 52, because first time we have 52 cards in a deck. Now, what is the probability of queen? Again, we have 4 queens in the deck, but only 51 cards are remaining. Outcome of the first draw has affected the outcome of the second draw. This is the important line. So here you have to change the denominator. You should be very careful about this denominator, right? So 4 aces, 4 by 52, and then 4 by 51, you can multiply these two. Formula for dependent events: probability of A and B. A and B means any event. A is any event, just like here in our case we have aces. What is the probability that you will pick ace in first attempt? What is the probability second event that you will pick queen in the second chance, right? So probability of A is 4 by 52, because we have 4 aces. Multiply, because in dependent and independent event we have to use the multiplication rule. Multiply probability of the second event, which is B, 4 by 51. In case of independent event, there is no need for this line. See, B, just you have to write down probability of A multiply by probability of B. But in case of dependent event, I see here this one, modification in notation. So just this is the modification. This line does not mean division. No, it means while probability of B event B, while event A has already occurred. So already the first is aces, you have to find out the probability of B. So probability of B is 4 coins. Now divided by 51, simplify it, you will get 0.006. If you will multiply in with 100, you will get in percentage. Second question, multiplication rule. This is the important point again. Can also be extended to 3 or more events. It is not necessary that you can have only 2, probability of A and B. No, you can have 3 or more events as well. 3 cards are drawn from a deck and not replaced. What is the probability of these events? Getting 3 kings. So see, now 3 events are involved here. Probability of 3 kings. First time you have 4 kings and 52 cards. Multiply by second time 3 kings, then 51, because now 1 card is less. In this case again, now you have 50 cards left and this 2. So multiply, just multiply the numerator, this is numerator, multiply the denominator and make it simplification, you will get 0.0002. Getting an ace, a heart and a diamond. So again see, there are 3 events, you can have more than 3 or 4. So probability of ace, heart and diamond. So first is ace, 4 divided by 52 initially, because there are 4 aces and you have 52 cards. Now you have picked 1 card, 51 is remaining. There are 13 hearts, 13 by 51, multiply by 13 diamond, 13 by 50, because 50 cards are remaining. When you will simplify this, you will get 0.0051. Right, so in this lesson you have learned how to find out the probability of the dependent event. If still you have any question, you can write down in comment section. Please do not forget to subscribe to my channel Saima Academy. Thanks for watching.